Today we'll start from the candidate elimination algorithm, that is second program of your machine learning lab. So the main aim of this program is, and the question is, for a given set of training data examples stored in a .csv file, implement and demonstrate the candidate elimination algorithm to output a description of the set of all hypotheses consistent with the training examples. So what it shows means, so we have to check we have to take the data in .csv file, and then we have to implement and demonstrate that data in the candidate elimination algorithm, and then we have to output the description of the input data, that is a set of hypotheses that which are consistent with the training examples. So this is our aim, and the training examples which are taken in CSV file are like this. So here also I am taking the Enjoy Sport example. So here also in both in finders algorithm and candidate elimination, in both the algorithms we are taking the same example as the Enjoy Sport example. So here same as there are four hypothesis values, and there are three positive value and one negative value. And the main drawback of finders algorithm is, so it won't check with the negative value. So but here in the candidate elimination algorithm, it will check the both positive and the negative hypothesis, and it will generate a specific hypothesis to to play the game. So it will make most specific to more general, and most generic to more maximally specific hypothesis. So here it will take both the negative and the positive examples, and it will generate the hypothesis for the concepts from training examples. So then we'll move on for the algorithm, and this is the candidate elimination algorithm, and the G specifies the maximally general hypothesis in total number of hypothesis space. H represents the hypothesis space, and S represents the maximally specific hypothesis in hypothesis space. G represents the maximally general hypothesis. S specifies the maximally specific hypothesis. Then for each training example D, in each training example D, do if D is positive. If the hypothesis is positive, then we have to remove from G. G is a maximally generic hypothesis. If the hypothesis is positive, then we have to remove the maximally generic hypothesis that is inconsistent with D. So we have to remove the maximally general hypothesis which are inconsistent with D. Then for each hypothesis, yes is some maximally specific values. So smallest implies the specific values, maximally specific hypothesis values in maximal specific hypothesis that is inconsistent with D. So if the D is positive, we have to remove the every hypothesis which are inconsistent with D, and also we have to remove the hypothesis values which are inconsistent in with D. So in both maximally specific general hypothesis and maximally specific hypothesis, we have to remove the inconsistent values. Okay, then remove S from S means we have to remove the inconsistent values from hypothesis, and then we have to add to yes all minimum generalizations H of yes such that H is consistent with the D. So H is consistent with D means, so we have to add values which are consistent with D. D is the total number of hypotheses. Total hypothesis, we have to add the hypothesis values which are consistent to main hypothesis, and then the second one is some member of G is more general than H. So in most generic, maximally generic hypothesis, some values are general than H. H means the hypothesis values. So that we have to uh, check all the we have to check all the hypothesis values. Then we have to remove from yes every hypothesis. Yes means the maximally specific hypothesis. Remove from the maximally specific hypothesis values that is the more general than another hypothesis. We have to remove all the values from maximally specific hypothesis which are more general than remaining hypothesis in most generic hypothesis. Okay, then next is if D is a negative example, then if the taken consistent hypothesis is the negative example, in that we have to remove from yes. Remove yes means most specific hypothesis. We have to remove the most hypothesis values which are inconsistent to D. D is the required consistent hypothesis, so that we have to remove inconsistent values from specific maximally specific hypothesis. For each hypothesis G, which is G means generic values in G that is inconsistent with G, remove G from we have to remove the each single values with a which are inconsistent with G. Then we have to add to G all minimal specifications H of G such that H is consistent with the D and some members of S is more specific than H. Then we have to remove from G that G is the more generic values, maximally generic hypothesis, every hypothesis that is less general than another hypothesis in G. So then essentially use the positive target examples to generalize the specific hypothesis and the negative target examples to specialize the generic hypothesis. So and then independent of order of training examples, and then convergence guaranteed if no error. Then the required output is the convergence guaranteed, that is if no errors then there is H in H in H means hypothesis values in hypothesis space describing the C means convergence. So here we have to make the positive example. If there is a positive hypothesis, then we have to make that more generalized from specific to more generalized. Then if the example which is taken is negative, then we have to make that as more specific to more generic. So if the hypothesis taken is positive, then we have to make more generic from specific. So if the hypothesis taken is negative, then we have to make it that as more specific to generic. We have to make more specialized. Specialized means more specific from generalized. Then this is the example. So we'll start with the example, the training data what we have taken. So the most specific hypothesis is represented with the 5 symbol. So this implies the most specific hypothesis, and G naught, S naught is the step 1 of most specific hypothesis. G naught is the most generic hypothesis, which is represented by question marks. So total there are 6 attributes. So here we have taken 6 files, and here total there are 6 attributes. So we have taken 6 question marks. Then we'll start with a recall if D is a positive. The first hypothesis is this one, right? So sunny, warm, normal, strong, warm, same. So this is first hypothesis. This is a positive hypothesis. And then if the hypothesis which is D is a positive, then we have to remove from G every hypothesis. This one is we have to remove. We make it if the hypothesis is positive, then we have to make it more generic hypothesis, maximally generic hypothesis from specific, right? So for that we have to remove from G every hypothesis inconsistent with D. So for each hypothesis yes in yes, for each hypothesis yes here, highest means smallest means number of values here, consistent hypothesis values in yes means total number of hypotheses that is inconsistent with the D. We have to remove inconsistent values. So this is the first hypothesis, so there is no inconsistent value, so we are copying the same with that is for specific values. We are copying the same, and we'll move on for the next one. So that here, this is a step one. So the second hypothesis is also positive hypothesis. At that time, we have to compare with the more specific hypothesis. Here, this one is a specific and this is generic. You have to, if the next next hypothesis is positive, then we have to compare with the specific, and there is no change in generic hypothesis. Okay, then we are comparing these. The specific hypothesis value to that is second hypothesis. The sunny and sunny is same, and warm which that is also same, and normal and high which is the values are changed, that is replaced with the question mark. So now strong and strong, that is also same, and warm that is also same and same is same. So there is no change in the generic hypothesis. Why? Because so in at the time of the positive hypothesis, we have to change the most values of the most generic hypothesis. We should not change the values of generic hypothesis. And then the third is, see, we are copying here the previous output. So, and while comparing with the next hypothesis, the third hypothesis value is negative. The third example is the negative example. So for that, so this is the negative example. So for that, we have to So for that, we have to change the generic hypothesis. We should not do any changes in the specific hypothesis. For this, we have to remove yes every hypothesis inconsistent with D. So we have to remove the every hypothesis which are inconsistent with the D. For each to remove that, for each hypothesis G, here G means number of values, total values, each individual values. Small g represents the each individual values, and the G represents, capital G represents the total whole hypothesis. Then with G, that is inconsistent with G, so we have to remove the values that are inconsistent here when we have to compare this hypothesis with the G here. So we have to remove the values that are inconsistent with the D. The D is this is the required hypothesis values, so we have to remove that, and then remove G from G, and then we have to add to G all minimal specializations G H of G that generalize some hypothesis in yes. Means we have to add the which are the minimal specializations of G that are generalized. We have to add the generalized values of minimal specializations. Then we have to remove from G every hypothesis that is less general than another hypothesis in G. We have to remove the generalized values which are less general than any other hypothesis values in G. So we have to remove less general values that are we have to comparing with all the hypothesis in generic hypothesis. So then we have to comparing this negative hypothesis with this. So here we are changing rainy, sunny and sunny. So then that should be changed with the sunny is the positive value. So then we'll start we have to compare with the rainy, and the positive values are sunny. So that this is not this, which is the rainy is the inconsistent value. So then that value is replaced with a sunny, and then cold is also inconsistent value. Why? Because the in positive example there is no cold value, so that should be replaced, and that is replaced with a warm, and the high should be, we have to check with the any examples, a positive example, whether the positive example is contains high, so that is consistent value. And then strong, whether we have to check whether the strong is consistent value. Yes, that is consistent value, then there is no change in that. Then warm and whether warm is a consistent value with a positive in positive hypothesis. Yes, there is a warm in positive hypothesis, so that is consistent value. So then we'll check with the change. So change, yes, change is a consistent value. So we'll make that. So same change here. The same change is not still not at generic hypothesis. Then we'll go through with the same. We are copying the same here. Change is a negative example, so we'll copy the same here. So the required hypothesis is sunny, warm, same. So then after this we'll go with the next one. Why next is, why are there no hypothesis left relating to cloudy? So cloudy is the cloudy is not consistent with the positive hypothesis. So for that we have changed, and normal is not the following specializations using the third value. Normal is not more general than the specific boundary. So normal is replaced with a question mark, and then the specializations weak. Weak and cool are also inconsistent with. Yes, so for that purpose we have taken the consistent values, and this is the required output of the third one. And then we'll check with the next consistent next hypothesis, and this will we have to compare the next hypothesis value for with the uh, previous hypothesis values, and then we'll compare. This is a positive hypothesis, then we should not change the generic values, we'll compare with the specific values. So sunny and sunny, that is sunny, and warm and warm, that is also same, warm. So high and question mark, it should be changed with a question mark, and strong, that is copied as same. And warm and cool, that is change with question mark, and change and same, that is change with a question mark. So this is the required specific hypothesis. And while coming with the generic hypothesis values, here warm, sunny, warm and same. So here sunny and warm are present in the specific hypothesis, but same is not present in the specific hypothesis. Then at that time contradiction occurs. This in generic hypothesis same is there, but in specific hypothesis question mark is there. So at that time same and the question mark, we should not write that, and that at that time contradiction occurs. So for that purpose it should be that same is changed as question mark. Why? Because the in generic in specific hypothesis only the warm, sunny and warm are present, there is no same. At that time we have changed with that with the question mark. So why the question same is changed means, why does this example remove the same means, this hypothesis cannot be specialized since would not cover the training examples, then cannot be generalized because more general would cover the negative training example. This hypothesis covers negative training example, then hence must drop the hypothesis. Then here we are check the next, this specific and the generic values are written like this. So here this is the most specific values, and this is the most generic values. Between those most generic and most specific value, the middle layer, that is called as version space. So this is the version space layer. So that can be represented as, version space can be represented as comparing with the both the hypothesis values. So here the most specific value is written as sunny and strong. Here we are taking the two values here of this hypothesis, sunny and strong. Here warm and sunny, but here warm and strong. So these can be, these three hypotheses are made with the use of with the help of this specific hypothesis. So from these values we have taken the generic hypothesis values. So from these two, most specific and most generic hypothesis, version space can be represented. So this completes your candidate elimination algorithm. So we'll go through with the program. This is the program for the candidate elimination. So here we are importing the .csv file. .csv file contains the input data for the program. So then after importing the data, you have to check with the domains. These are the examples. Examples means the hypothesis. Hypothesis we are importing, we are checking the set of hypotheses, and then we are listing the hypothesis values, and then if the G is represented as the most generic hypothesis, S represented the most specific hypothesis. More generic hypothesis can be written as question mark. Specific hypothesis can be written as zeros. To make more generalized, to make the hypothesis more generalized, here we are making the most generalized hypothesis. If the if the value is consistent, then we are making that value or copying that value as question mark. So here we are copying that value as a question mark, and then we have to check with the consistent values. So here whether the hypothesis is consistent, we are making the more general, and the minimum we have to check with the minimum generalizations. So minimum generalization, we are comparing the generalized values with generalized hypothesis. H represents the H copies the hypothesis, and X copies the hypothesis values. It will check all the hypotheses with for the minimum generalizations. So then we are making the we are defining the most generalized values here. So if the value is consistent, then it will check with the most generalized values. If the value is not consistent, then that value will be deleted. So then we are making the most specific to minimum generalizations. Here we are making the most specific to minimum generalization. If the value is not most generalized, then that value will be removed, and then we are making the minimum generalizations here. So after making the minimum generalization, we are making the minimum specializations. Here we are making the most generalized to minimum specialization. Minimum specialization means maximally generic values. So here that is if the value having the question mark, then that is minimum general maximally generalized, and then else if the value is having the 0, and that is most generalized value. Then if the value is 0, we are appending that value to hypothesis, resultant hypothesis, and then we are checking the most specific values. So if the value is consistent, then only it will add. If the value is not consistent, that value will be removed. So here we are making the most specific values. Most specific value means we are making more generic hypothesis. We are more generic to more specific hypothesis. After making that, the candidate elimination will work. So it will initialize the more generic value and the specific generic and the specific hypothesis, and then it will check with the each and every hypothesis values, and then if the hypothesis value is consistent, then only it will add. If the value is not consistent, it will remove. It will check for the more generally consistent value and more specific consistent values here, and then it will print. the candidate print the output. So these are the four hypotheses that we have taken. So after this, this is the first step. This is the most generic, more generic step and more specific step. After making the generic and the specific changes, so this is the step one, step two, this is step three, and this is the final step. This is more generic and more specific hypothesis. G represents the general hypothesis, S represents the specific hypothesis. So this completes your candidate elimination algorithm. If you have any doubts, you can ask.